Hello folks, we come to the part 4 video of this exercise 1.3, and here we are going to continue with that same idea of getting the inverse of a given function and showing invertible and all that. So let's continue with that process. They give us a function f from r to closed interval 4 infinity, which is defined as fx equal to x squared plus 4. They ask us to show if f is invertible and whether f inverse x is equal to root of y minus f inverse y should be f inverse y is root of y minus 4, whether it is existing, that you have to check. Okay, so for our convenience, let g from 4 infinity to r be g of x equal to root of x minus 4. Then you can consider g of at x. So that is g of f of x, that is g of x squared plus 4 f of x, and g of any value is going to be root minus 4. You put that value in the root minus 4. Obviously this will cancel. Root of x squared we know is x, so we've got g of f at x as x. Also, if we consider f of g at x, that means it is f at g at x. Okay, g at x is root of x minus 4, so f of the value is square of it plus 4, so square of this plus 4. That's how we define f. So square and root, because they are opposite operation, they'll nullify each other and we'll be getting x minus 4 plus 4. That can cancel each other, you're left with x. Therefore f of g at x is x. Thus f of g at x is x and g of f at x is also x. Therefore f is invertible and f inverse is g. That's what they have asked us, right? So that's about the inverse of the 8th question. In the 9th question also, they give us a function f from r plus to phi infinity and they define f of x. They ask us to check whether this is going to be an inverse or not. So let's do the same thing. Define g from phi infinity to r plus as g of x as root of x plus 6 minus 1 by 3. Consider f of g of x, that is f of g of x, that is f of, now f of any value, what it is, it's quite complicated. It is 9 into the square of this value plus 6 into this value minus 5. So what is it going to be? 9. Now square of this is going to be 9, so that can come out. Let's take the square of this. Square of x, root of x minus 6 is x plus 6 is x plus 6 plus 1 a squared plus b squared minus 2ab. So minus 2 root of x plus 6. Now here this can cancel. So when you open the bracket, it is 2 root of x plus 6 minus 2 minus 5. This is also simplifying. And what all is happening here, you're having x plus 6 plus 1 minus 2 root of x plus 6 plus 2 root of x plus 6 minus 2 minus 5. This can cancel. 6 plus 1 is 7. This is minus 7. So they will cancel. Finally, we are left with x. So f of g of x is x. Then we consider g of f. Let's see. F of x is 9x squared plus 6x minus 5. G of a particular value is root plus 6. Root of 9x squared plus 6x minus 5 plus 6 minus 1 out of the root and 3 down. So what will happen? This will become 1. 9x squared plus 6x plus 1 is nothing but 3x plus 1 the whole squared. So this is actually 3x plus 1 the whole squared. root n squared, so 3x plus 1 minus 1 by 3. So thus GOF at x is x and FOG at x is x. Therefore F is invertible and F inverse is G. So that's how we have shown how the invertible is very important in the board exam for 4 marks. Earlier it was a favorite question. Now of course the marking scheme has changed, so here and there are changes, but they're very important, these questions, very important from the examination point of view. So that's all about this. With new problems, we'll meet in the next video. Thank you.